the field of electromobility for passenger cars, it has long time been an intensively discussed topic in research whether the electrical energy comes from a battery or hydrogen and a fuel cell. For passenger cars, it is now relatively clear that the direction is towards batteries. In applications with much longer operation times, such as buses, trucks, or ships, it is not yet clear, and fuel cells are also used in stationary applications. In this video, you will learn how a fuel cell is structured and how it works. You will also learn how the functional principle of the fuel cell could also solve the storage problem of the energy transition in the area of long-term storage. In a fuel cell, hydrogen and oxygen react to water, releasing energy in the form of electricity. The cell is structured as follows. It consists of two electrodes, between which a voltage is applied during operation, via which a consumer, for example an electric motor, can be operated. Between the two electrodes is an electrolyte and a membrane in the middle that is impermeable to hydrogen and oxygen. Ions, on the other hand, can pass through the membrane to the other side. At the negative electrode, hydrogen is added and the hydrogen molecules give up two electrons and become two hydrogen ions. These H+ ions can now migrate through the membrane to the other electrode. At this electrode, oxygen is added and reacts with the hydrogen ions and two electrons to water. The electrons migrate via the consumer from the negative pole to the positive pole, causing a current flow. If new hydrogen is always added to the negative electrode and new oxygen to the positive electrode, a consumer such as an electric motor can be operated continuously. The voltage at the cell is 1.2 volts in no-load operation, i.e. as long as no current is flowing, and somewhat less, usually just under 1 volt, when a current is flowing during operation. There are different types of fuel cells which differ in the materials of the electrodes, the membrane and the electrolyte. With some fuel cells, it is also possible to use methane as fuel instead of hydrogen. In this case, methane reacts with oxygen to water and carbon dioxide. But both methane and hydrogen are fuels that can theoretically also be burned directly in a gas engine and thus be converted into motion without the diversions via a fuel cell and an electric motor. In addition, the lithium-ion battery is being used more and more in electromobility, which is an alternative to the fuel cell. So what are the differences between these technologies and what are the advantages and disadvantages of the fuel cell? Compared to the engine, the fuel cell generates electrical energy. This can be used for all electrical consumers. So in mobile applications, there is no need for a generator, often called an alternator in this context, for the electrical consumers. The biggest advantage compared to gas engines is efficiency. While an internal combustion engine can only achieve efficiencies of 40 to maximum of 50%, a fuel cell can achieve efficiencies of 60 to 70%. In addition, in some applications, it is an advantage that fuel cells are very quiet compared to engines. Disadvantages are the relatively expensive storage of hydrogen compared to other fuels. Fuel cells are also relatively expensive. Compared to batteries, which also provide electrical energy, an advantage of fuel cells is the possibility to separate the storage of the fuel cell from the cell. The costs are thus mainly dependent on the necessary power, but not on the amount of energy that can be stored, similar to an engine with a fuel tank. The disadvantage of the fuel cell here is also the complex storage of the hydrogen and the associated dangers or costs. In addition, efficiency is also a disadvantage here. Although the conversion of hydrogen into electrical energy is relatively efficient, losses also occur in the production of hydrogen. This makes a lithium-ion battery much more efficient when it comes to storing electrical energy. The advantages and disadvantages result in different areas of application for fuel cells. one hand, fuel cells are used as fuel cell heating systems. Here, both electricity for the household or feeding into the grid and heat are generated, with a high overall efficiency of up to 95%. In addition to stationary applications, mobile applications are also interesting for fuel cells. Due to the independence of power and stored energy, applications in which the fuel cell is operated for long periods at a time, such as in buses, trucks or ships, are particularly interesting here. Fuel cells are also interesting in submarines because fuel cells are much quieter than combustion engines. The functional principle of the fuel cell can also be reversed, and hydrogen and oxygen can be produced with the help of a voltage and water. In this way, electrical energy can be converted into hydrogen and stored. This could become an essential component of the energy transition in the future. If you want to learn more about the energy transition, watch this video now. If you liked the video, please leave a like and subscribe to the channel.